Hello again. I'm going to show you how to draw the Lewis structures on this worksheet from Monday, May the 4th, Star Wars Day. And the directions at the top of this page are not super important right now as far as naming the compounds go, and we haven't learned how to identify the shapes yet. What I want you to do is focus on whether you can actually draw the structures or not. So I'm going to walk you through how to do these as we start with the first one here, phosphorus tribromide. We're going to put phosphorus in the middle because we've only got one phosphorus, and then we've got three bromines, so we're going to put some bromines around it. Then we're going to add up the electrons. And phosphorus is in group 15, so it's got 5 valence electrons, and each of the bromines has 7. So we add those up and we get 26 valence electrons or 13 pairs. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the 13th pair just goes right there on top of the phosphorus. And it's done. In number 2, for NH3, we're going to have a nitrogen and 3 hydrogens. If we add up the electrons, we've got 5 plus 1 plus 1 plus 1, which adds up to 8 or 4 pairs. So we go 1, 2, and 3 to connect everything to the atom in the middle. And then we just slap the 4th pair right there on top of the nitrogen. Because keep in mind, hydrogen is weird. It only needs the one pair of electrons that connects it to the atom in the middle. You don't put extra electrons around a hydrogen. In number 3, NO2, we've got nitrogen in the middle, and then we've got 2 oxygens. And we add up the electrons, and we've got 5 plus 6 plus 6. We add those together, we're getting 17, but we have a -1 charge and electrons are negative, so we've got an extra electron. So that's 18 or 9 pair. So we go 1, 2, 3, 4, 5. I like to save the atom in the middle until the end. 6, 7, 8. Then we're going to put our 9th pair on the nitrogen, but oh no, look at this, the nitrogen is still short a pair of electrons, so it needs to share. So it can either borrow a pair from the oxygen on the left or the oxygen on the right. So if we borrow from the oxygen on the left, it would look something like that. If we had borrowed from the oxygen on the right, it would look something like this. And you don't have to borrow from both. We only needed the one extra pair of electrons on the nitrogen so that everything has 8 electrons around it. So that's how the NO2 minus molecule works. And then we need to, because it's got a negative charge, we need to put some brackets around it and a -1 on there. So that one's pretty complicated. Let's go to something a little simpler. CH4. We've got a carbon and 4 hydrogens. We add up the electrons. We have 4 plus 1 plus 1 plus 1 plus 1. That's 8 or 4 pairs of electrons. 1, 2, 3, 4, and we're done. Next, we've got the sulfite polyatomic ion. It's a sulfur with 3 oxygens, -2 charge. So I've got a sulfur. I've got 3 oxygens. If we add up the electrons, everything's in group 16. So we've got 6 plus 6 plus 6 plus 6. So we add that together, it's 24. We also have a -2, so add 2. That gives us 26 electrons or 13 pairs. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And pair number 13 goes right on top of the sulfur. And it's got a -2 charge. And number 6, this is carbon dioxide. You might be familiar with that. You're exhaling it probably right now. We've got carbon in the middle and 2 oxygens. We added the electrons. Carbon has 4 valence electrons. Each oxygen has 6. So that adds up to 16 valence electrons or 8 pairs. So we go 1, 2, 3, 4, 5, 6, 7, 8. Now, this is a problem because carbon does not have 8 electrons around it. It's only got the 2 pairs that it's sharing with the oxygens. So we need each of these oxygens to share a pair. So the oxygen on the left can share a pair of electrons, and the oxygen on the right can share a pair of electrons. And so we end up with this nice symmetrical looking thing that's got 2 double bonds in it, and that's carbon dioxide. You do not make a triple bond on one side. Triple bonds are like the bond of last resort. You don't do it unless there's really no other option. Next, we have silicon dioxide. So we have silicon in the middle and some oxygens. If we add up the electrons, we have 4 plus 6 plus 6, which is 16 pairs. This looks familiar. That's 1, 2, 3, 4, 5, 6, 7, 8. We're short some electrons on the silicon in the middle, so we need to borrow some pairs from the oxygens. And it looks just like the carbon dioxide, which, since carbon and silicon are in the same group, have the same number of valence electrons, it should kind of make sense that it works that way. And number 8, we've got carbon disulfide. So we've got carbon in the middle and 2 sulfurs. We add up the electrons. Carbon has 4. Each of our sulfurs has 6. It's 16 pair, 16 electrons. I don't know why I called those pairs. 16 valence electrons or 8 pair. We'll fix this real quick. So this is going to look exactly like the other 2. Because oxygen and sulfur are in the same group, so same number of electrons. Number 9, let me just point out real quick that this right here is chlorine. It is not a carbon and an iodine. This is the polyatomic ion perchlorate. It's also got a -1 charge. I don't know if you can really see that minus sign there. It was just a minus sign, but that means -1. So a little bit tricky there. So we're going to have some chlorine in the middle. We're going to have some oxygens all around. We add up the electrons. We've got 7 plus 6 plus 6 plus 6 plus 6. We add that up. That's 31, which is not a good number. That's an odd number. But we have the extra electron. It's 32 valence electrons or 16 pair. We've drawn one similar to that already. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. The only thing we need to do to finish this one off, stick a -1 charge on it. This brings us up, last but not least, to dihydrogen sulfide, which is a really smelly compound. But we're going to put sulfur in the middle We got our two hydrogens. We added the electrons. We've got 1 plus 1 plus 6, which is 8 valence electrons, or 4 pair. So 1, 2. The hydrogens don't need any more electrons, so we just put the extra 2 pairs right there on the sulfur, and we're done.